Okay, this tutorial is going to teach you two key themes that come from the National 5 Geography course. The first one is land uses in glaciated upland landscapes, and the second one is conflicts because of those land uses. Now, in the center of this video you can see a large pipe coming down off a mountainside, and this is a hydroelectric pipe carrying water from a reservoir up there above the hill, and I'll include a map to show you that, down to a power station at the foot of the hill. Now, why this landscape is so suited to the generation of hydroelectricity is, first of all, we are in the mountains, in this case of Scotland, and it's a very wet climate, and hydroelectricity requires a continual amount of rainfall coming out of the sky on a regular basis, which recharges the loch that will be high up in the valley, the reservoir I should say. So the weather that you find in mountainous areas suits the generation of hydroelectricity. The second thing you need in a hydroelectric model is a steep gradient which to run your pipe down, because the water needs to flow from the upper reservoir up there to the lower reservoir or to the power station and build up speed as it moves down a hill. And therefore you need steep gradients in order to run your pipes, so you can generate that high velocity of water which is going to turn the turbines. A third feature of your landscape that you're going to be looking for is a really remote area with very little other development. As we can see, there's very little else in this area. And why is that appropriate? Because you are going to be building a large dam up there, as well as pipes and power stations, and they all potentially create conflict, especially with local residents who are not going to be happy with these types of developments. So if you're in a remote region, you're not likely to have much opposition to your development. A further advantage of this landscape is we have a granite landscape. The surrounding geology is granite. Now, that's an impermeable rock. That's quite important because when water hits the landscape, what you want it to be doing is staying on the surface, in this case in the reservoir up there. You don't want it draining into the rock in a process we call percolating. Granite is an impermeable rock. What that means is it doesn't allow water into the landscape, and it stays on the surface. And that allows you to then build up the reservoir on the surface, which you can then pipe the water down from. So we've got four really positive attributes. Other key features that make this a suitable location for our hydroelectric power station is we have roads that can be used for workers at the power station to be able to get access, but also maintenance that's going to require access to the pipes and the cables. So there are 5 reasons, with a good bit of detective work using a photograph or using an ordnance survey map, that you could use the evidence to suggest that this is a highly suited landscape. Because it's glaciated, we have the steep valley sides created by the glaciers it ploughed through, and we're also likely to have a hanging valley up there in the distance, which is the valley that's been dammed and that's creating the reservoir. So in this first part of the video, I've explored why does this landscape suit hydroelectric power, and I've given you 5 pieces of evidence from what I can see and what I know about the landscape, which I could also get from a map if I was using an ordnance survey map to answer that question. If you watch the second part of this video, you'll gain an insight into the kind of conflicts that this generates.